Hi, myself C.H. Venkateshwarlu. I working as assistant professor in electronics and communication engineering in St. Martin Engineering College. My topic is rectifiers. What is mean by rectifier? What is mean by rectifier? Rectifier is convert to AC to pulse DC, that is called rectifiers. Okay, it is mainly used of two types of the rectifiers. Two types of the rectifiers: half wave rectifier and full wave rectifier, and bridge rectifier. It is the three types of the rectifiers: half wave rectifier and full wave rectifier, bridge rectifier. It is called three types of the rectifiers. Okay, I will explain about the first. Basically, I will going to the first of all main important of the diodes. In this, using the main important of the basic component diode. What is mean by diode? The diode is two terminal device. The diode is two terminal device. One is the anode, another one is the cathode. Anode is connected the positive terminal, cathode is the connected the negative terminals. Okay, I will draw the symbol of diode. Diode, it is the positive terminal and negative terminal. Positive is connected to the anode and negative terminal connected to the cathode. It is diode is the connected the two biases. One is the forward bias and another one is the reverse bias. Okay, first of all I will connect it the first. The diode is connected to the forward bias. Forward bias, the positive is connected to the battery of the positive, negative is connected to the diode of the negative is connected to the diode of negative terminal. It is the positive and negative. It is called forward bias. Another one, the diode is connected to the forward bias. The diode is on condition. Another one is the reverse bias. The reverse bias is nothing but diode positive is connected to the battery of the negative. Diode negative is connected to the battery of the positive. That is called reverse bias. Okay, diode is the forward and the reverse bias is nothing but, and the diode is the on and off condition. On and off condition, the diode acts per switch. Diode acts per switch. Diode acts per switch. One of the application of the diode. Diode is the one of the application. Okay, it is main. My topic is rectifiers. My topic is the rectifiers. Rectifier. What is mean by rectifier? Rectifier is nothing but it is convert to AC voltage to pulse DC voltage. That is called pulse DC voltage. That is called rectifiers. Rectifiers is nothing but it is following of the three types of the rectifiers. First one is the half wave rectifier. Half wave rectifier. Rectifier, and following are the full wave rectifier. Full wave rectifier. Full wave rectifier. Full wave rectifier. Another one is the bridge rectifier. Bridge rectifier. Okay. Bridge rectifier. The rectifier is the one of the application main important of the one of the application. Okay, it is very important of the application of rectifier. One of the application of the rectifier. It is rectifiers is main basic components of using basic components. Number one is the transformer, another one is the diode, and third one is the resistor, load resistor. Another one is the load resistor. Okay, it is the main important of the transformer. What is mean by transformer? Transformer is nothing but static device. It is the electrical energy one form to one circuit to another circuit. It is nothing but transformer. Transformer is nothing but two types of the main important of the two types of the transformers. First one is the step down transformer. The second one is the step up transformer. Step up transformer. Okay, in the circuit main important of the I can using the step down transformer. Step down transformer is the very important of the step down transformer. Main important of the step down transformer. Step down transformer. What is mean by step down transformer? Step down transformer is nothing but the increase to decrease level, voltage level, that is called step down transformer. increase and decrease level is nothing but a convert to AC to AC voltage to DC voltage, that is called step down transformer. AC voltage to DC voltage is nothing but step down transformer. Step down transformer is increase to decrease voltage. Increase voltage is nothing but apply the 230 voltage to is convert to DC voltage is nothing but 12 voltage. 12 voltage, that is called step down transformer of voltage levels, increase and decrease of the step down transformers. Another one is the step up transformer. Step up transformer, it is very important of step up transformer. Okay, step step up transformer. Step up transformer is nothing but the converts to AC to DC. AC to DC is nothing but AC voltage is nothing DC to AC. Step down transformer is nothing but that is the decreased to increase is nothing but step down transformer. It is the main important of the in this circuit using step down transformer. In this circuits using step down transformer. Okay, another one is the second one is diode. Diode is very important of in this circuit. What is the purpose of diode? The diode is the two terminal of device. Two terminal of device. It is the positive terminal, another one is the negative terminal. Okay, positive terminal is nothing but anode, another negative terminal is nothing but cathode. It is the diode is the two terminal device. Diode is the, what is the number of diode? IN4007. The diode number is the IN4007. Okay, diode is nothing but it is the connected the two biases. Okay, first one is the forward bias. Second one is the reverse bias. The reverse bias. The first one is the forward bias is nothing but diode is positive terminal connected to the voltage of the positive and negative terminal is connected to the battery of the negative, that is called forward bias. Okay, it is the diode is connect to the on condition. Diode is acts for on condition. Diode one is the connected to the on condition. Another one is the reverse bias. Reverse bias is nothing but the diode positive is connected to the battery of the negative. The diode negative is connected to the battery of the positive. That is called reverse bias. Diode is the off condition. The diode is the off condition. And it is the diode is the two biases conducting, forward bias and reverse bias. The diode reverse bias of diode number IN4007. That is the forward bias and reverse bias. Forward bias is the diode is on condition and reverse on condition, and reverse bias is the diode is the off condition. That is why diode is acts for its switch on it. Diodes for acts for switch, that is the connected the two biases. Diodes for acts for switch, and diode main important of the diode of applications using rectifiers. Rectifiers using main diodes, and another one is the resistor. Resistor is the basic component of resistor. The resistor is the which flow of opposition current. It is the resistor. Resistor is representation of capital R. The units of ohms. That is the resistor. In this diode, connect the forward bias. Diode is on condition. Diode is connected the reverse bias. The diode is the off condition. The diode is the on and off condition is nothing but it is the diode is acts per switch. Diode is acts per switch. In this circuit, the voltage is increases and resistor will be in this circuit diode in current will be increases. The resistor will be decreases. The resistor will be increases. The current will be decreases. That is the use of resistor in this circuit diagram of the resistor. In this circuit, supply the load resistors. Load resistance is nothing but RL. RL is nothing but load resistance. Okay, it is the use of important of resistors of a rectifiers. Okay, first of all, I will discuss about the of a rectifier. Of a rectifier, of a rectifier, of a rectifier is very important of in the circuit diagram. Main apply the using transformer, step down transformer. Okay, I can draw the simple transformer of symbol. It is the number of turns of the primary. Primary is the past in this circuit. Secondary is the transfer. Secondary is the secondary coil, and transformer is positive is connected to the diode positive, and diode negative is connected to the transformer negative. Transformer negative, that is the negative. That is the apply the input signal of AC 230 volts, 230 volts of AC voltage, and frequency is the 50 hertz. Frequency is the 50 hertz. It is the apply the input voltage. It is apply the input, the simple circuit of the symbol of the transformer. Transformer is the primary and it is the secondary coils. Okay, it is the number of turns. It is using of the step. It is the transformer. Transformer is nothing but step down transformer. It is the step down transformer. Step down transformer is secondary is positive is connected to the diode positive, and diode negative is connected to the transformer negative. It is the diode is the that is the diode is the on condition. It is the connected the forward bias, and diode negative is connected to the transformer of negative. Diode is positive is connected to the diode transformer negative positive. That is nothing but diode is connected the reverse bias. Diode is off condition అవుతుంది. Off condition. You can using of the apply the of a rectifier. Of a rectifier, apply the input signal that is the V in, and the x-axis I will take the time period. Okay, what is the units of time period? Seconds. Voltage as units are volts. Okay, apply the in positive cycle, positive half of the positive cycle, and 0 to 5, that is the half of the first cycle 0 to 5 intervals, and the second half cycle of the negative, that is the intervals of 0 to 25, that is the apply the input signal of AC voltage. Okay, it is the 0 to 5 total positive, one positive cycle, one negative cycle is nothing but one cycle. One positive cycle, one negative cycle is nothing but one cycle 0 to 25. That intervals are 0 to 25. That is nothing but input signal. Okay, apply the in this circuit, apply the input signal of one positive cycle, one negative cycle. It is a total one cycle. You can observe that transformer positive is connected to the diode positive, diode negative is connected to the transformer negative. It is connected the forward bias. The diode is on condition. Okay, apply the, you can observe the output waveform. V out 0. It is the positive cycle. The diode is connected the forward bias. Diode is the on condition. That is the positive cycle is the on condition. Okay. Next one I will go to connected, the diode is connected the reverse bias. The transformer negative, diode is negative is connected the transformer negative. Diode is connected, positive is connected the diode negative, diode positive. The diode is connected the reverse bias. The diode is the on off condition. You can observe the input and output. Output, the second cycle of the cycle, the diode is the off condition. off condition. The diode is connected, the forward bias is on condition, and the reverse bias is connected, the diode is the off condition. It is the main important of the off-air rectifier of on and off condition. It input and output waveform. That intervals of 0 to 5 is the positive half cycle. The negative half cycle is the 5 to 25. 5 to 25 is the second half cycle. That is the total cycle of intervals 0 to 5. It is the input and output of the half-wave rectifier. Input and output of the half-wave rectifier. It is main important of the across the load. Main important of the across the load. Load is the main important of, even increase the current, rest will be decreases, and rest will be increases, current will be decreases. That is the main across the diode is connected to the forward bias, and the current will be flow up across the load resistance. Diode is the on condition. Okay, the diode is connected to the reverse bias in the circuit, and the reverse bias, the diode is the off condition. The diode is the off condition. The off condition, that is the second half cycle is the connected the reverse bias. In this across the load is the off condition. That is the on and off condition is nothing but off-air rectifier on and off condition is nothing but it is the on and off condition. Okay, off-air rectifier main important of the output to DC voltage. DC voltage is the what is the off-air rectifier of DC voltage? The Vm by 5. That is the IDC current is equal to Im by 5. It is the main important of voltage and current of parameters. In this circuit, main important of parameters. The first one is the DC voltage, and the second one is the DC current, and another one is the ripple factor of off-air rectifier. Ripple factor of off-air rectifier 1.21 is the ripple factor of off-air rectifier. And in the circuits of main off-air rectifiers, and fourth parameter is the efficiency of off-air rectifier. That is the efficiency of 40% of the efficiency of the off-air rectifier. In this main important of the parameters, number one is the DC voltage, second one is the DC current, and another one is the ripple factor, and another one is efficiency. Okay, it is the main important of, and the frequency of the off-air rectifier output, frequency of the output frequency F, that is the output frequency of off-air rectifier. Okay, in this off-air rectifier applications is the very low cost and design the very simple and main important of the off-air rectifier applications. Okay, off-air rectifier main important of the application, number one is the low cost. It is the very low cost, very low cost. The diode cost is very cheap. And another one is the simple, you can off-air rectifiers using required only one diode of off-air rectifier. Another one is the simple constructions of off-air rectifier, design and simple constructions of off-air rectifier. It is the simple constructions of off-air rectifier, and I will go to another one is the full-wave rectifier. Full-wave rectifier in the circuits very important of the full-wave rectifiers. Okay, full-wave rectifiers is nothing but it is the using full-wave rectifiers is main important of in this circuit diagram. Okay, it is using main important of full-wave rectifier using two diodes, diode 1 and diode 2. Okay, diode 1 and diode 2 is the using two diodes are using full-wave rectifier. Main basic components full-wave rectifier and transformer, number 1, 2, another one is the diode, and third one is the load resistance. Load resistance is nothing but flow of opposition current is nothing but load resistance. The resistance is representation of RL. RL is the load resistance, and it is the main important of units. It is the ohms. Okay, in this circuit, main important of the using step down transformer. Step down transformer is nothing but increase the voltage to decrease the voltage levels. That is nothing but a step down transformer. Full wave rectifier in this circuits using D1 and D2. Okay, another one is the transformer, another one is the load resistance. Okay, load resistance using diode one is connected the positive terminal of diode transformer, negative terminal connected to the transformer negative. It connected the forward bias. Diode one is the on condition, and diode two is the diode one is connected. Diode two is the reverse bias. Another one, next one is the diode 2 is positive terminal connected the transformer of the positive, and a negative terminal is connected the transformer of the negative. That is the diode 2 is the on condition. Diode 2 is the on condition. The diode 1 is the off condition. That is the simultaneously diode 1 and diode 2 is the simultaneously on and off condition full wave rectifier. Full wave rectifier in this circuit, main important of full wave rectifier circuits, which is the convert to voltage into pulse DC voltage using the both off cycles of the applied the DC voltage. It can using the two diodes. Okay, two diodes. You can using the two diodes. Two diodes are the one diode is forward bias, another diode is the reverse bias. Okay. The explain about the main important of the full wave rectifier input and output waveform. It is the first of all diode one is the on condition is the positive cycle is one positive cycle is off on condition. Another one is the diode is connected the reverse bias. The diode two is the off condition. Okay. Next one is the diode one is the on condition. Diode two is the on condition and diode two is the off condition. That is the diode 2 is the on condition, nothing but the D1 is G2 is the on condition, D1 is the off condition. So it is the combine of the both diodes. Diode 1 and diode 2 is the both diodes are on condition. That is simultaneously, that is the on and off the it is the simultaneously on and off condition is nothing but full wave rectifier. Okay, full wave rectifier very important of the main full wave rectifier of the main important of the applications, very important of the applications. Advantage and disadvantage of full wave rectifier. Okay, first one is the low ripple factor, another one is the high efficiency, high transformer utilization factor. So transformer utilization factor is the very important of in this advantage. Okay, another one is the disadvantage. Disadvantage, it is the more complicated than half wave rectifier, and additional diode is the bulky utilization transformer are needed. In this disadvantage, main important ఏంటంటే require the one more diode, and another one is the more important bulk or needed the additional diode అన్నట్టు. It is the high cost of half wave rectifier. Okay, it is the applications of half wave rectifier. Another one is that is the bridge rectifier. In this circuit, very important of the bridge rectifiers. Bridge rectifiers is nothing but it using of the 4 diodes. Okay, in this basic components of bridge rectifiers, transformer and 4 diodes and across the load resistance. Okay, it is the main important of the basic components of bridge rectifier. Bridge rectifiers you can using the step down transformer. Step down transformer is nothing but increase to decrease of the AC to DC voltage. It convert to increase the 230 volts, you convert to DC voltage of 12 volts. It is nothing but step down transformer. Another one is the using 4 diodes. Diode 1 is and diode 2 is connected to the forward bias. Diode 2 is the during of the first half cycle D1 and D2 conduct the conducting, and while D2 and D4 is the off condition. Okay, off state. That is the D1 and D3 is the on condition, and D1, D2 and D4 is the off state. It is the first of the off of the cycle. Okay, another one is that the D2 and another one during the first half cycle D2 and D4 is conducting while connected, and the diode is the forward biases, and D1 and D3 is the off state. That is nothing but off state. That is the nothing but reverse bias of bridge rectifiers. In this circuits, main important of four diodes. Can using of the four diodes, and I can observe the main important of bridge rectifier input and output waveforms. Okay, I apply the input signal of sine wave of V in input signals. Okay, and observe the D1 and D3 is the on state, that is the past cycle is the on state. Another one is D2 and D4 is the off state, that is the second cycle is the off state. And another one is the DC current output waveform of during of the D2 and D4 is the on condition, and D3 and D3 and D1 is the off state, that is nothing but reverse bias. That is nothing but reverse bias. Okay, you can using combine the D1 and D1 and D3 and output waveform, and D4 and D2 is the output waveform, is combined the both cycles is nothing but on and off condition. Simultaneously you can on and off condition is the bridge rectifier input and output waveforms. Okay, another one is the important of very important of bridge rectifiers. Bridge rectifier is the main applications of important of the application. It is very important, high efficiency and ripple factors. The transformer utilization of I and peak inverse voltage is reduced across the diode. And simple and small circuit of the bridge rectifiers. It is the main important of the bridge rectifiers in these circuits. The comparison between rectifiers. Okay, in these parameters, first one number of diodes, another one DC voltage, peak inverse voltage, and ripple factor, rectifier efficiency, and transformer utilization factor, form factor. In this number of half wave rectifiers using only one diode, full wave rectifier using two diodes, and bridge rectifier using only four diodes. Okay, it is the main important of the VDC, half wave rectifier VDC Vm by 5, full wave rectifier voltage is the DC voltage Vm by 5, and another one is the bridge rectifier DC current is the Vm by 5. That is the ripple factor is the 1.21 is the half wave rectifier, full wave rectifier is nothing but 0.48% ripple factor, and ripple factor efficiency 40% of half wave rectifier, full wave rectifier 81.2% and 81.2% of the bridge rectifier, and the transformer utilization factor of half wave rectifier 0.28 and the full wave rectifier is 0.69, 0.28 is the bridge rectifier of the full wave rectifier. The comparison between the half wave rectifier and full wave rectifier, bridge rectifier, the total parameters of small information of the comparisons. Okay, another one is I will go to the next video. I will explain about the video. It is main important of the video, though the rectifiers. Rectifiers I will apply using of the half wave rectifier and full wave rectifier and bridge rectifier, and the diode is connected, the positive terminal connected to the battery of the positive, negative terminal connected to the battery of the negative, that is called forward bias. And another one is the reverse bias is nothing but positive is connected to the battery of the negative, and battery of the positive is connected to the diode is negative, that is the reverse bias, that is called diode is off condition. And I will apply the input voltage, you will observe the depletion layer is increasing, that current will be decreasing, and apply the input potential voltage, and deflection region decreases, the current is increases, the current will be increases. Okay, it is the main important of in this video. The main important of in this video, full wave rectifier and half wave rectifier and bridge rectifier, and on and off condition. I will check the on and off condition. So diode is X per switch, X per switch. Diode is the one of the application in using rectifiers. Okay, in this rectifier using main important of the positive terminal and negative terminal. The positive terminal is positive is connected to the battery of the positive, the negative is connected to the battery of the negative, that is nothing but negative, that is the forward bias. Okay, the positive is connected to the battery of the negative. The negative is connected to the battery of the negative. That is nothing but reverse bias. The reverse bias, the depletion region width is increasing. The current will be decreases. Okay, in this video, thank you.